Now we're going to do the 5.9 part 2. So you'll have an additional kind of problem in your homework set, and I think this is kind of fun. It's a little bit different. The learning target finding finite differences in a polynomial function. So let's define what finite differences are. The differences of consecutive y values when the x values are equally spaced. So here's what the problems will look like. Show that the equation has third order differences. So here's our equation. And we're going to show that it has third order differences this way. First, what you need to do is find consecutive y values. For a third order difference, you need at least 5. So that would be the minimum that you could have. So I'm going to find out what happens when I plug in 1, when I plug in 2, when I plug in 3, 4, and 5. Now I'm not going to show you the work for this, but remember you can use direct substitution or synthetic substitution to get these values. When I plug in 1 for all the x's in this equation, I get out an output of 2. And when I plug in 2 for all the x's, I get 11. And 3, I get 36. When I plug in 4, I get 83. And when I plug in 5, I get 158. Now, you're going to have to do it, like I said, with either direct or synthetic substitution and write them all out like I've done here. Then what you're going to do is you're going to subtract 11 minus 2, and that would be 9. And then you're going to do 36 minus 11, and that would be 25. And then 83, you always do this one minus the previous one. 83 minus 36 would be 47. And then our last difference, remember difference means subtraction, so that's why I'm subtracting. 158 minus 83 gives me 75. When you do this the very first time, this is called a first order difference. We actually did do these in Algebra 1, when we were trying to write equations for input-output tables. Now we're going to do this again. 25 minus 9 is 16. 47 minus 25 is 22. And 75 minus 47 is 28. And this would be a second order difference. Okay, we're going to do it one more time. 22 minus 16 is 6. And then 28 minus 22 is also 6. This is how you show that this has a third order difference, because after the third time the differences were constant. They will always be 6 here, and that's called a third order difference. Something else that's interesting is you know it'll be a third order difference because of the degree of this polynomial being 3. So if the degree is 4, you're going to need a few more numbers here, do at least one more to get down to the fourth order degree. You need at least 2 numbers on the last row to prove that they're the same. And that's how you show. This shows that the equation has third order differences.